Okay, so if I have the quadratic here, I'm going to fix the 5 points that I'm familiar with. Okay, and that is my parent function. Let's call it p of x. And I'm interested in looking at a transformation that moves all the points on this function to the right, let's say. Okay, so I'm going to graph it first just to see what happens. So if I say 1 unit to the right, so translate, this is my job right now, translate p of x 1 unit to the right. Okay, so I'm going to take it graphically and move every point starting with the vertex 1 to the right. Okay, and I'm going to call that, let's say, f of x. And I'm going to create an expression for each of these, right, just to see what happens in terms of the algebra that indicates that translation to the right. So if I look at p of x, do we remember the expression for the parent function, or the quadratic? Y, yeah, f of x is equal to x squared. But in fact, in vertex form, we have an x minus 0 all squared plus 0, just to highlight that vertex, okay? And this is one important aspect of quadratics, because if you look at it in terms of the vertex, oh, that's p of x, yeah. So if you look at it in terms of the vertex, it shows you the translation is quite a bit nicer than the other standard form. Okay, so we have p of x. That means f of x here will be what if I look at it in vertex form? The vertex being at 1, 0.
X minus 1.
It would be an x minus 1, yeah, for the vertex, all squared, and then plus what?
0.
Plus 0. Okay, so all I'm doing is looking at the vertex for now, and then we'll establish a bit more what's happening. Okay, and then I'm going to try to move it, let's say, 3 units down. So still from the original, but I'm going to go down here. So my goal is translate f of x 3 units down. Okay, so again, all the points that I can see will be moved down by 3. And there's a bit of overlap in one, but that's okay. So what would be the vertex in this case? There's a 1 and negative 3 for y. And I'm going to take this and express it in, let's call this g of x. Okay, so a g of x, I shall use orange, I guess. So g of x is, again, there's no stretch or compression, so the a is 1. We have an x minus 1 from before. And what happens to the k value now? Minus a 3, that's right. Okay, so if I were to just give you the expression for g of x, you would know exactly which way p of x has traveled, right? Vertically and horizontally. So if you're adding, for example, within your x term there, so if I had x plus 1 all squared, which direction would it go? And compared to x squared? To the left, okay? So we're not talking about patterns yet, but just an overall. The idea with quadratics is you always want to put it in a vertex form before looking at anything else. Okay? And if the vertex moves, then all the other points move. That's why we're just using the vertex to count, right, the measurement. So let's go with a radical 0, 0, 1, 1, and 4, 2. And we'll have the same task. We'll move it, let's say, 1 to the right. Actually, let's go left this time. So translate p of x 1 unit to the left. So just graphically, I'm going to take all my points, p of x, and that was root x. I'm going to take all of them to the left, we said, so to 0 to negative 1, 1 to 0, and the 4 to a 3. Okay? Yep, we switch direction. So this is, let's say, f of x. So for an expression, I can think of what happened there. Again, not the vertex, but it's some sort of starting point for the function. So it's moved from a 0, 0 to a negative 1, 0. So the y stayed the same. So for y of 0, I've moved to negative 1. So how can I figure out the equation there? What would be one way to look at it? Just expression-wise. What do I have to do to x so that the y stays at 0? It would be plus 1, right? So let's see here, x plus 1. Because if I substitute in negative 1 for the x, I get back my value of 0, right? And we'll do a check here too, just to convince ourselves. But the idea is you always consider your domain. So if you look at the domain and make a check here, x greater than 0. Here I have x plus 1 greater than or equal to 0. Right? So if I move the 1 to the other side and solve the inequality, I get my domain as x greater than negative 1. So you can always double check your domain through this. Okay? So now we'll take one more and move it downwards. What do you think will change here if I move it downwards, the x or the y? The y, okay. So we have translate p of x, well actually let's say f of x. I'm going to keep going, f of x, 2 units down. Actually let's say up, sorry, 2 units up, just to see what happens here. Okay, so this will be called our g of x. And we'll figure out the expression of it, but now let's take all the points and translate them 2 units up. So what happens there? I still have a root x plus 1 because I already took care of the horizontal translation, but vertically, what have I done to the y value? Increased it or decreased it? Increased it by 2. Okay, so I have a plus 2 in the expression for the actual transformation. So if I follow just with that starting point, it's gone from a 0, 0 to a negative 1, 2. So I automatically know that it's gone 1 to the left and 2 up if I just focus on that one point, okay, the starting point, because all the other ones will follow that very first starting point. Okay? So one more function, and then for the linear, I'll give you some time to think about that one. It's not more complicated, it's just there are 2 interpretations, and I'm sure you'll enjoy them. So what's the function left that's not linear that we haven't discussed yet? The what? The rational, okay? So what crucial points come to mind there? The 2 points that I start with? 1, 1, and negative 1. Okay? And then a bit of symmetry left and right. So that is my p of x. And we'll do the same. So let's say translate to the right. By, let's say, 2 units. So I'm going to take those 3 points, well 6 in total, and just move them over to the right. So this half will now go to 2.5. The 1 will go to a 3, and the 2 will go to a 4. Okay, I'm not going to draw them yet, and you'll see why in just a little bit. And we'll do the same for these ones. So negative 2 goes to a 0, negative 1 goes to 1, and 1.5 from negative 0.5. Okay. Now I'm going to remind myself of what the expression is for p of x. So the parent function, what is the expression for that? 1 over x, yeah. So I immediately write down my asymptotes. I know x is not, so asymptotes, x0 and y equal to 0. And we usually try to label those, x0 and y0, so that we can get a better visual. Because what happens when you translate, because all the points move, the asymptotes will move as well. Okay? So many times it's best to just go with the asymptotes, draw those first, and then you can go with the other points following the asymptotes. Okay, so what I'm going to do here, even though I have those 3 points, is list the asymptotes for the function that I'm going to. So if I'm moving 2 units to the right, that means the asymptote goes to a 2. Okay? So x is equal to 2. So I'm going to draw that out in dotted lines. X is equal to 2. And now I can use that to graph it a little bit easier. The y stays at 0. We're not translating in the vertical direction, so this will stay at y is 0. Okay, so we have there, that's our f. Yeah, let's call it f of x. So if I describe it, I can go from the asymptote x is equal to 2 into an equation form, right? So if I move the 2 to the other side, what do I get there? X minus 2. Okay. And it works both ways. The asymptote you get from x minus 2, etc., etc. Okay, so now I'll let you draw the graph, maybe for a function going upwards by 1 unit. It's going to get a little bit... it's a little too much. Maybe we'll do that in an example, okay? Let's leave it for now. You know which direction it would move. You just draw the asymptotes, and we'll do that in an example. So I'll draw just the linear for now and give you 5 minutes to discuss. Well, maybe just 3 minutes. We'll see. Okay, so the linear parent function, what does it look like? X. Not just x, but y. Yeah, y is equal to x, okay? So let's draw that out, and I will give you a mission. Okay, so this is my f of, well, parent px is equal to x, or y is equal to x. And I will say translate p of x 3 units to the right. It's not supposed to be a trick question. It's just it will hopefully raise some questions. So graph and expression. 3. It's a 3. You don't have room for 8. Okay. Is Jody here today? No? Okay. You like to chat? So expression.
No, it's -2 minus 3 would be -5. It works that way.
The expression is defined to spread the second one really just moving to the right. Last year is everyone
Yeah, well, I can give you.
Yeah, there's another aspect you should be discussing in terms of directions. That's all. It's a good thing we lose confidence.
Why does it?
No,
-3.
that's just a reminder.
Why are you making it so complicated? Did you go to x minus 3? Because that's
Okay, so I think most people have the answer. Okay, the expression is what? F of x.
equals x minus 3.
I have an x minus 3. I'm always focusing on this central point, okay, the 0, 0, the starting point, and moving 3 to the right. That means all the other points, and there's no stretch, no compression, will line up, okay? So everybody had this, I think. But then what I wanted you to discuss was, it is in a way related to the y-intercept, but I can also describe this, even though it says 3 units to the right, how else could I describe it? Because I can count this point as moving, moving down 3, okay? So this is the one function where you get a bit of freedom in the description, okay? So 3 units down as well. Not as well, but are, okay? So it's not both of them. It's one or the other. Okay? It's not actually undergoing 2 transformations. You can just describe it in 2 ways. By, let's say, 2 units. And label. Okay, so let's have some fun with the examples. Oh, tips, right. Linear, so focus on one direction. And choose the 0, 0 of the parent as a guide in graphing and in describing it algebraically. For the quadratic, what did we say? What was the main point there? Yep. Put it into, that's right, vertex form. So focus on the vertex form. And use the vertex to interpret the transformations. Okay, for the radical, we're focusing on the starting point. So starting point of the parent, or you can think of it as the starting point of the domain and range. And for the rational one, the main aspect was, sorry? The rational, well, yes, you always fix those 2 points, but what tool did we use for easy graphing? The asymptotes, okay? So focus on the asymptotes to guide the direction of the transformation. Each translation. Okay, so this is where I give you a function, a parent function, and maybe two transform. And we'll start with the... We just did a rational at the top, but we only had one direction. So let's say p of x is 1 over x. And then you'll graph an f of x that's 1 over x plus 5. No, let's say plus 3. And a g of x that's 1 over x minus 4. So I'll give you a 2-minute head start, but I'll cover it with you in a second. So first I make a list of asymptotes on my right. And I'm always comparing, the comparison goes px to each of these. I'm not comparing g of x to f of x. I always compare back to the parent function. So this one would be a horizontal translation, 3 units to the right. Okay, I'll freeze it at this point, so you don't go hand in hand. But everybody's set up for success here, right?
Yeah.
Should I take it up, or is everybody being successful?
For the g-rex,
Yep.
we go from the x into the function.
Well, what is the expression? 1 over x minus 4. Is anything happening horizontally?
No.
Nope.
But do you move the parent function, or do you go from?
From the parent. So you always compare things to the parent.
I did it. I did it.
Okay, so let's go through this together. So everybody has the asymptotes, right? For f of x, we have x is negative 3. So I'm going to draw out my asymptote. I'm not going to bother graphing the parent functions, just to show that it's possible to graph the transformed without the parent. Okay? So I have here an x is negative 3, quiet. And I'm going to take all the points that I expect. So y0 stays, the horizontal asymptote stays there. I will have a point right here, which is 1 away from the asymptote, 1 to the right and 1 up from the other, and then 1 here. So I'm just using my symmetry. I don't even need, I'm going to erase these points because I don't officially need those parent ones. Right? I have the two asymptotes, the y0 and the x is negative 3, so I'm just guiding myself by those in terms of counting the points left and right. Yep.
Should it be horizontal translation to the left?
Oh, it is to the left. Yeah, thank you. The r, I put the r in there. Yeah, that's right.
And you can decrease it out.
Yeah, no, it's to the left. Okay, so we have one of them here, and again, I don't need the parent function. But Jasper, highlight here, you do want to show your graph extended all the way through, okay? Even though it's translated, make sure you cover the entire graph. Arnav, is it clear?
The same height as the other ones. So if that draw, that's
Yeah.
like the number inside.
Yes. Okay. Good luck.
Thank you.
Play well.
Bye, Arnav.
Make sure you win. No pressure. Okay. Okay, so make sure that you cover the entire grid for these. I know that you're tempted to just draw the 3 points, but make sure that you complete the graph, okay? So this here is my f of x. And somebody asked if it's necessary, Jasper, if it's necessary to look at the previous function or just the one. So in this case, I do not, once I've drawn f of x, when I go to g of x, it's not important to recall f of x. G of x is independent, right, of f of x. I'm always comparing to the parent function. Okay? When we drew the lesson before, when we were deriving all of this, we did build one on the other, but in general, you always go back to the parent function to compare. Okay? You're only going back to x0 and y0 for a rational function. So I have my horizontal translation drawn. The vertical translation has to be 4 units down. So again, I'm not going to use any sort of help in terms of a parent graph. I'm going to go with the asymptote. So the asymptote is a y is equal to negative 4. And I also have x is equal to 0 as one of the other asymptotes. So the points, it's a bit difficult to draw here, but I have one point right here and another one here. And symmetrically, I have a half going up there, a half going there, and here. Okay? And you can still draw it well enough. that will be enough showing the asymptotes and showing the starting point of those graphs, the one on the left side. So this is my g of x.